So here we go. Let's go over some of the problems of the test that you had this last Friday. And I was kind of surprised that not so many of you guys, but there was a great number of students who basically just have no idea how to do any of these problems, in which they're so similar to the ones you had on the multiple choice. I mean, not all of them, but some of them are very similar. So you were able to do it on the multiple choice, but when it comes to the written part, where you have to show work, you get lost. So in this particular case, you're asked to write in simplest form. And so you want to take the first derivative. They're asking you for the first derivative. There was A, B, C, D. So if I want to find the first derivative, the first step is rewrite 4x minus 1 to the half power. So dy dx, drop the power 1 over 2 and you subtract 1. That will give you 4x minus 1 to the negative half power. But then I just took care of the power. I still have to take care of whatever's inside. So the derivative of 4x minus 1 is just 4. Rewrite 4 times 1 is 4 over 2 the square root of 4x minus 1, and I put it on the bottom since I have a negative power. So now you can reduce, and that becomes 2 over the square root of 4x minus 1. So not so many people had difficulty with this one. The next one, well, the usual stuff. People like to mimic. They thought of this as 3x to the third power, which is not true. But because, we did a bell work, people just mimic. Alright, so dy dx is going to be the derivative of cosecant, which is negative cosecant of the argument 3x to the third cotangent argument. But that's just the outer function. I still have to pay attention to my inner function, which is now 3x to the third. So I have to take care of the derivative of 3x to the third. And when you do so, 3x to the third, bring the power down, multiply times 3, that should give you 9x squared. Rearrange everything, and you should have negative 9x squared, cosecant 3x to the third, cotangent 3x to the third. And that was the end. Alright. C. Well, here I have two things to worry about. So first, I have the quotient. A quotient rule needs to be applied. Also, the power rule, since I have power, and also I have to use chain rule, since I have functions inside 3x plus 1. So the derivative is dy dx. Low, what's my low here? 2x minus 1 quantity 4. 2x minus 1 to the fourth power. Times the derivative of the numerator. So I'm going to write just d for derivative of 3x plus 1 to the third, minus high, which is 3x plus 1 to the third power, times the derivative of the bottom, all over everything over 2x minus 1 to the fourth power. raised to the second power because log square. Alright, so now let's do it. 2x minus 1 remains the same. But the derivative of 3x plus 1, we have a power here. So at first I have to worry about the power. Drop the power. That gives you 3. And you're left with just the power of 2. And bring everything inside the parentheses. 3x plus 1. Okay? Times. So I've took care of the power. Now I have to take care of whatever's inside the parentheses. 3x plus 1, the derivative is just 3. Minus. High stays the same. But now the derivative of the bottom, again, let's take care of the power. Drop the power, multiply 2x minus 1 to the third power. So I've just took care of the power now. But I need to go back inside and multiply by the derivative of 2x minus 1, which is just 2. All over 4 times 2, 2x minus 1 to the 8th power. It is not 6. But anyways, people just forget their algebra. So let's clean this up. So now we have 2x minus 1 to the 4th power. 3 times 3 gives you 9. 3x plus 1 square. 4 times 2 gives you 8 minus 8. 3x plus 1 to the third. 2x minus 1 to the third. All divided by 2x minus 1 to the 8th. So, do we have any greatest common factor? Well, I have 2x minus 1. I have 2x minus 1 right there. Do I have any more common factors? 3x plus 1, 3x plus 1. So, these are my greatest common factors. So I'm just going to factor out So if I pay attention to 2x minus 1, I can factor out the lowest power, which is 2x minus 1 to the third. So that goes away. In terms of 3x plus 1, so I know here I will just have 1 left. 3x plus 1, the lowest power between the two is 3x plus 1 to the second power. So that will go away, and I'm just going to have one of them left. So I'm just going to open brackets. And then the 9 times 2x minus 1. And then I have minus 8. And then minus 8 times 3x plus 1. This is minus. All over 2x minus 1 to the 8th power. Can I reduce anything? Yeah, 3 of these will take 3 away from 8. That should give you 5. So now you have just 3x plus 1 square. Simplify the inside. That gives you 18x minus 9 minus 24x minus 8. And that should give you minus 6x minus 17 all over 2x minus 1 to the 5th power. And that's your answer. Simple stuff. Alright, now let's take care of this one. Quotient Rule. So I'm writing all over the place, which is okay. For x, 5 minus x. Okay, so I'm going to erase some of this so I have space to do my work. Alright, so let's do it here then. dy dx, I have two functions. product rule. So I'm going to do is I'm going to do f prime g plus g prime f. And again, it doesn't matter which one you select as long as you keep track of your product rule. So I'm going to do 4. The product of the derivative of f is just 4, and g will stay the same. Plus sign. Some of you guys are putting multiplication. It is plus. And now g prime, so that means that 4x remains the same. This I'm going to write as 5 minus x to the half. When I take the derivative of this, I'm going to take care of the power. So drop the power, and you still have 5 minus x to the negative a half times. So I just took care of the power, but I still have to go back inside and multiply by the derivative of 5 minus x. And the derivative of 5 minus x is negative 1. Okay? So now it is just 4 square root of 5 minus x plus 2 goes into 4 is 2. That gives you 2x right here times the negative. That gives you negative 2x, the square root of 5 minus x. So I drop it because of the negative power. So I want common denominators. So multiply this by square root of 5 minus x, the square root of 5 minus x, and therefore we get 4 times 5 minus x minus 2x all over the square root of 5 minus x. And we get distribute the 4. That should give you 20 minus 4x minus 2x all over 5 minus x, the square root, and that should give you 16 20 minus 6x over the square root of 5 minus x. And that's perfectly fine. So this is your derivative. Okay? This right here. A lot of you. Okay. Horizontal tangent lines you set the derivative equal to 0. You do not evaluate the derivative equal to 0. That doesn't mean that you let x be 0. No, you set the derivative equal to 0. For vertical tangents lines, we know that the slope of a vertical tangent line is undefined. So that means I want to have my slope to be something, a number over 0. So I want to know what will make this undefined. That means that the denominator has to equal, you set it equal to 0. What will make the denominator equal to 0? So they're telling you that this particular curve has the derivative as negative quantity x plus 1 over 2 quantity y to the third plus 1. So since I want vertical tangent lines, I want to set the derivative, the denominator of my derivative equal to 0. So this section right here is my denominator. I'm going to set it equal to 0 since I want something of this form, a number over 0. Alright, so I'm going to take 2 quantity y cubed plus 1 equal to 0. If you divide by 2, you still get 0. So you get y to the third plus 1 equals 0. Y to the third equals negative 1. You take the cube root of negative 1 and you get negative 1. And the answer is negative 1 because negative 1 times negative 1 times negative 1 gives you negative 1. And the cube root means find a number that when you multiply it 3 times gives you whatever is inside the radical. In this case, it's negative 1. But I want the coordinates of the 2 points. And I'm telling you, there are 2 points. Alright, so that means that I'm going to have 2 points in which the y coordinate is negative 1, which is right there. but I want to know the x.